Yes, sir.
So in page 9, see the match the column, part 3. Okay, so we start solving question number 9. Then I'll come back to that question. So first you read the question, read the option also, and then go back to graph, check for slope, check for area, and see if you can get the column B, column 2. So you can match the column accordingly. So first you try for a while, then I'll come back to this question. Okay, so I think that is sufficient time. We can discuss the solution one by one. So the first graph is Vx graph. And the graph is a straight line. So it's a linear graph, right? Am I audible, guys?
Yes, sir.
Now, if you look at the first graph, it is linear graph. So how you write the linear graph? Passing through origin. So what is the equation of a straight line passing through origin? In terms
X
of y,
equals Y.
x equals to y, or we can say y equals to mx, some constant into x, right? And if it is exactly 45 degrees, then y equals to x. So y equals to mx is the equation of any straight line passing through origin. What is y here?
P.
And what is x here? What is x here?
Displacement.
X is x only, right? Now, how to write the acceleration in terms of x and v? Acceleration we write as
V dV by dx.
what is dv by dx? What is the dv by dx representing? So dv by dx is representing slope of vx graph, right? Do you realize this? Yes or no?
Yes, sir.
Now, once dv by dx represents the slope of the vx graph, look at the graph. And what do you think? The slope is constant or variable?
Constant.
So can we say this is v into some constant? Can we write like this? And what is v itself? Some constant into x into some constant. So can we write this a is some constant into x? Tell me.
Yes, sir.
Can we say a is proportional to x?
Yes, sir.
So the acceleration is constant or variable?
Constant.
Acceleration is constant or variable? Acceleration is constant or variable?
It's variable. It's depending on X.
It is dependent on x, so it must be variable, isn't it? Siddhant, tell
Yes.
me.
Yes, sir.
Now you have to read the option and tell me which option is matching the scenario for the graph A. Read all options, all the four options.
So Q and S.
Excellent. So how many of you realize that the answer is Q and S? So if you have really understood this part, that A will have the answer Q and S, then B, C, D, all graphs will have the similar beginning. And in each case, you have to find the acceleration. Okay. And then get the options. So now try the B, C, and D part, everyone. Okay.
Should be is Q.
So what is the answer?
P is Q.
Okay,
C is
B.
Q and R.
Okay. So B is how much?
Q.
Q and only Q.
Yeah, only Q.
Okay, great. And the C,
Q and R.
Q and R, and D.
And D is Q.
D is Q. Siddhan, tell me.
Sir, I got B is P,
B is P.
C also P,
Okay.
and D I got QR.
And D is
QR.
Q R. Okay. Anybody else who would like to say something? So can you try, Harry? Look, I think if you have not seen before, you can leave. If you want to try, you can try. Questions are tell me what you got the answer. In every graph, you have to begin with y equals to mx, and then take the slope and try to relate what? Slope with acceleration. Okay. Why? Because slope is constant. So the B graph is between what? The B graph is between
V square and X.
V square and x. And slope is constant. So can we write V square equals to mx? The first part. Can we write like this first of all?
Yes.
Yes, sir.
Can we differentiate both sides? Or simply
Yes.
can you find the slope? So dv square by dx is how much? M. Slope is constant, right? And how to write dv square by dx using chain rule? So we can write dv square by dv into dv by. So what is the d by dv of v square? Two v dv by dx. Yes or no? Tell me.
Yes, sir.
And this entire term is called
Acceleration.
so acceleration is m by 2 half of slope, and this is what we did in the last lecture. In the v square s graph, acceleration is half of slope, 1 by 2 times slope. Here slope is constant. So here a is constant. So which option is giving you constant acceleration?
Option P.
Very good. So P is the only answer. Okay. Now go back to the next part, C part. In
But
C
I had a
part,
doubt in the second step.
which step? Here.
Oh, the second step. So after v square equals to mx, what happened to the x?
So if you look at the graph, and okay, anyway, if you differentiate both sides with respect to x, what will happen? X will vanish. Look at this. V square equals to mx. Differentiating both sides. We have done this many times. Differentiating both sides with respect to x. What will happen? D by dx of v square on the LHS, on the RHS, d by dx of mx. What is m here? Constant. So the LHS we can write using chain rule. And the RHS m is outside. What is the dx by dx? Tell me. Tell me.
1.
So what will get 2v dv by dx equals to m? right?
Alright.
And v dv by dx is called acceleration. So 2i of acceleration is m. So what is acceleration? Half of the slope. So you have to start with the y equals to mx, differentiate both sides. And because we know the slope is constant, so that's why this is the equation. So just differentiating will give you all the answer. In the C part, which graph we have? Tell me guys, C part.
VT graph.
VT graph. So V equals to MT. So dV by dt will be how much? If I differentiate both sides with t. And dV by dt is called, by definition,
Acceleration.
it's a famous graph. No? It's a VT graph. We know slope of the VT graph is acceleration by
Yes, sir.
definition. So acceleration here is constant or variable.
Constant.
So again, which option?
P.
P option. So what's the big deal? P is correct. And the D part. In the D part, what graph we have? First of all, tell me graph.
V by T square.
VT.
V and T square, right? And here slope is constant. So what we can add? V equals to y equals to
MT square.
MT square.
MT square. Very good. MT square. So once you're at MT square, can you differentiate both sides with respect to time t? Can you differentiate both sides with time t?
Yes, sir.
So on the LHS will get dV by dt or RHS will get 2MT. Yes or no?
Yes, sir.
Okay. So what is d by dt meaning? dV by dt represents.
Acceleration.
Acceleration.
So acceleration here is proportional to what? Time t. Yes or no?
Yes, sir.
So which option is correct? Because it is proportional to time t, so is it constant or variable?
Variable.
So is it uniform or non-uniform?
Non-uniform.
So the option is Q and R, which is the right answer. Any doubt in this question? Tell me, guys. Prashansa, Rugved,
No doubt.
Siddhant,
No
Harry?
doubts.
Okay,
No doubt, sir.
very good. Come back to page 13. Everyone, page 13. In page 13, can you see the comprehension one? Everyone, see and read the comprehension one. After reading, attempt the question from 1, 2, 3, 4. The time given to you is 6 minutes. And then I'll solve. So everyone read carefully, interpret the graph. And if you're able to interpret it correctly, it's pretty easy question. If you fail to interpret, it's pretty difficult question. Anyone getting the answer?
Yes.
Okay, so for option question 1, what is the answer?
Minus 10 meters per second. A. Oh,
2,
0. Yes.
3,
So third one, I'll find it.
4th,
So third and
So third one I can.
tell me how much?
I can.
I can. Who is saying?
Check ratio.
Okay, proceed. Siddhant, you got the answer?
Sir, on the
Rugved?
third and fourth ones.
Yes, Rugved, you tell me. How many answers you got?
First one I got.
So this is the graph of XT graph. In XT graph, what we know? What we know in XT graph? What we can get from XT graph? Tell me.
Velocity,
velocity.
Velocity. By looking at the
slope.
slope of the tangent. Okay. So you have to just check the slope of the tangent. I think angle itself is given. So what is the slope, guys? If you know the angle, then slope is written as
Tan theta.
tan theta. All right. So I hope you should get the answer. So the average velocity, how we write? Average velocity is defined as
Total displacement upon total time.
total time.
and how you find the displacement by the way? Displacement is defined as
Shortest distance between points.
no, this is not the definition in class 11th. This is the definition in class 9th. What is the definition of displacement? What is the definition of displacement? Anyone? What is the definition of displacement? If you don't remember, go and check your notes and tell me the answer. What is the definition of displacement, guys?
Distance from origin.
Are you guessing the answer or telling the answer?
I am telling.
That's wrong. So displacement is defined as change in position vector. Can you recall, everyone? Change in position vector. So you look for the final position, you look for the initial position, you subtract the initial from the final. So in this journey, what is the final position?
Minus
What?
100.
And what is the initial position?
100.
So what is the displacement here? Displacement is how much?
minus
Come on, guys. Minus 200. And time is how much?
20,
20.
So what is the average velocity?
minus 10.
Minus 10. How to find the average acceleration? What is the definition of acceleration? Average acceleration is defined as how we define? What is the average acceleration, guys? Tell me.
Delta
Rate
V by
of
delta
change
T.
of
Delta
velocity.
V vector by delta t.
Pardon, once again. Average velocity is defined as, sorry, average acceleration is defined as. Yeah, person, sir, tell me, you were telling
So
something.
delta V vector by delta t.
Yeah, delta V upon delta T. Change in velocity upon time.
Yeah.
So to find the change, what you do? You find the final velocity minus initial velocity. And in XT graph, how to find the velocity?
Slope.
By finding the slope.
So what is the slope of the graph at the end of the journey?
Tan 120.
Tan 120. What is the slope of the graph at the beginning of the journey?
Tan 120.
So what is the difference of velocity?
0.
So what is the average acceleration
0.
for the 20-second, right?
Yes.
Yes.
What is the direction of acceleration during the first 10 seconds? So to find the direction, you can find the average acceleration. So what is the average acceleration sign, not the value, for the first 10 seconds? So at 10, do you see any angle?
0. Angle.
Although it's not 0, but you can take 0, that's okay. So what is the velocity at 10? So at 10 seconds, what is the velocity? At the instant of 10 seconds, if you draw the tangent, you will get some answer close to 0.
0. Close to 0.
And at the beginning, it is a big negative.
Minus root 3.
So your answer is plus or minus. So the common sense is that if you go from A to O, you can say from beginning to up to 10 seconds, if you simply look at the tangent to the graph, the tangent is decreasing, yes or no? Tangent is decreasing?
Yes, sir.
Okay. And velocity is positive or negative? The slope of the graph between A to 10, like you can say from A to the bottom 0, if you draw anywhere tangent, what you will see? A positive slope or negative slope?
Negative.
Slope is negative. So velocity is positive or negative?
Negative.
Negative.
And also as you come down, the slope the slope will become less, or you can say lesser and lesser steeper.
Yes, sir.
Yes, sir.
So the magnitude of velocity is decreasing.
Yes, sir.
So is it decelerating? Is it decelerating or accelerating?
Sir, accelerating.
No, it is decelerating. The value is decreasing, no? As you go from beginning to up to 0, A to 0, the slope is continuously decreasing, isn't it? So steepness represents the magnitude of velocity, or you can say speed. So you're slowing down or speeding up. In XT graph, what we see? We only see slope. So as you come down from A to 0, tell me the slope is decreasing or increasing in value wise, not symbol wise. Numerically, the steepness is decreasing or increasing. Tell me.
Steepness is decreasing.
So decreasing steepness means what? The magnitude of velocity is.
Decreasing.
So you're slowing down or speeding up.
Slowing down.
So when you slow down, then it is a retardation or acceleration. It is.
Retardation.
And when you retard, then acceleration and velocity should be opposite sign or same sign.
Opposite sign.
And what is the sign of velocity here? Positive or negative?
Negative.
So what should be the sign of acceleration?
Positive.
Positive.
So the answer should be plus I or minus I.
Plus I.
Plus I is the answer. Do you understand that?
Yes.
So this was the tricky one. It's very simple. Just read the see. This question is why difficult because most of the students they fail to read the entire simple XT graph, and that's why I said in the very beginning, the most complex graph is XT graph. Rest is simple. And the fourth one, time interval during which the motion is retarded. It's very simple.
0 to 10.
So we have discussed that part already. So the A option is 1A, 2, C,
To see.
3, plus I, and 4, C. You can check the answer if you wish to check. Okay. So we have done almost all graph. And now we are going to start one-dimensional motion in vertical direction called motion under gravity. Okay. Let's begin that chapter. Motion under gravity. So if you consider this earth, so compared to the earth, what is the radius of earth? Anyone knows? Earth radius?
6400 kilometer.
And what is the tallest building on earth? Tallest building on earth.
Burj Khalifa.
Burj Khalifa. And how big is Burj Khalifa? Any guess?
820 meters.
Yeah, so it is less than 1 kilometer, right? Roughly 848 or 840 meters. Now 6400 kilometer. And if you compare even the tallest building, so how high is the tallest building on earth compared to the earth radius?
Negligible.
So can we draw the entire Burj Khalifa by drawing this dot?
Yes.
Yes.
Yeah, so that's much bigger than Burj Khalifa basically, but you can imagine that as Burj Khalifa. So in practical life, when you throw something, you throw almost close to surface of Earth only, isn't it? So for you, it may be the highest six hit by the batsman. But compared to the Earth dimension, you remain at the surface. And because of this practical usage or scenario, we never travel to a distance which is anywhere significant compared to the Earth radius. It is always insignificant. It is always insignificant. It is always insignificant compared to the Earth radius. So we assume the object at the surface, even though you travel few hundred meters. So traveling even few kilometers is like on the Earth's surface. And therefore, because when we consider such motion into consideration, the gravitational acceleration which the Earth's gravity creates, that acceleration we assume to be constant. Now, when you launch satellite, so how far the satellite goes? Is it going close to surface or very far from surface? So when we launch satellite, do we go far away from Earth's surface or close to Earth's surface?
Far.
Very far, right?
Oh,
So when we talk about the satellites and their motion, then gravity will change or remain same during their, you can say, launch. What happens? So as they move away from the Earth, the gravity acting on that spacecraft, that satellite, will change or remain same. What will happen? So for satellites, gravity will act in a same fashion or will keep on changing? Tell me, guys. Hello, hello, hello. This is a simple question. Am I audible to you?
Yes, sir, it will change.
Yes, tell me. Harry, you can tell. This is a simple question.
Sir, it will change.
It will change. Rugved, what will happen? Will it change or remain same?
It will change.
So that is why the study of satellite will never follow the uniform gravity, but the study of projectiles. Like in cricket, you throw object, you throw ball, sometimes you throw bat also. That's not recommended, but you can throw. So in a game of badminton, lawn tennis, golf, all these object which is flying off, they are moving so close to Earth that the variation of G for their journey can be ignored or can be taken as constant. So such motion which you study, in which the object moves close to the Earth's surface, we never consider the variation of G. We believe that you are very close to Earth's surface, and therefore you are basically in uniform gravitational field. First thing. Second thing is, even you are playing the game of golf, and if you hit the ball, the farthest it can go is next to this dot. Because how far it can go, even if you hit? So will it go kilometer away? Mostly not. So it will go few meters away and will come back to Earth, yes or no?
Yes, sir.
So again, although Earth is round, but when you throw something, you remain on the same horizon. So we assume that the entire motion is taking place over the horizon. You're not bending down. So the ball is not going to hit this part of Earth. No. So however fast you may throw, it will land almost next to this point. But at a scale that we live, we feel that it's very far, but on a scale of Earth, it is moving close to a dot. So all these assumptions are part of motion and gravity or projectile motion chapter. So that will be your next topic. So motion under gravity talks about those motion in which the particle moves in uniform gravity. And because the gravity is uniform, you will also come to know under uniform gravity, you accelerate uniformly. So when you accelerate downward, you accelerate uniformly. In real life, there is a problem. In real life, the air resistance plays a bigger role. So if someone has gone for the skydiving, you can understand how big the air resistance is. Or in case of paragliding, also can explain the air resistance and how it affects the motion. But again, in this chapter, to make things really simple, we are not going to consider the effect of air resistance. Although air will be there, but our motion is not such that the air will create some disturbance which will affect the motion significantly. So the air will be there or will not be there. You can assume whatever you want to assume, but air resistance will not affect our motion. So motion under gravity means the controlling power should be in the hand of Earth only. Or you can say only Earth should govern the motion. Okay. So that is the idea of motion under gravity. Therefore, motion under gravity, as well as the next topic called the projectile motion, we are going to study under the assumption that the value of G is not changing for the whole course of motion of the object, as well as there is no effect of air resistance. There is no effect of air resistance. So we'll write something called assumption. So before we study, we need to know the unsaid assumptions. Okay. So what is the first assumption? Tell me, guys.
Gravity is not changing.
So variation of G, what we call acceleration due to gravity at close to Earth's surface, we call variation of G, which is of course a value basically 9.8 roughly we take meter per second square. And this value we don't write as a value, we write as a symbol called G. So variation of G is ignored. Now I'm not saying it is not changing, I'm saying it is ignored. So the change is so small that it is good to ignore. First, what is the second assumption, guys?
Air resistance is neglected.
Correct. Again, this is not, see, of course, we cannot avoid air, but as of now, we are going to ignore it. I mean, although it's there, we are going to ignore it. So air resistance is ignored. There's a third assumption as well. But again, because of the small distance journey, compared to the Earth dimension, the journey is really small, unless we are not, participating in the World War where we have to launch a missile which can go from one country to another country. Okay. So we have BrahMos, Agni, and so many other missiles which can really travel in kilometers. And when missile will travel, then air resistance will play a role for sure. But there is something very interesting which we generally avoid, which is called the rotation of Earth. So Earth is constantly spinning on its axis, right? So let's say if I fire a bullet, and if you really talk about the person, let's say you want to kill a person, you're here and you want to kill the person here. So let's say you know all of the physics, and let's say Earth is rotating about this axis. Imagine. The moment you fire a bullet, imagine the bullet will come here, but by that time the Earth will turn, so the man will go somewhere here, right? After turning. So even though your target is very much fixed, your aim was very much perfect, still the rotation will drift away the object along. So the surface of the Earth is in motion, so while leaving the bullet will bullet will travel through the air, but the man will shift the position because of the Earth rotation. But again, these things happens over a very, very large distance, and this effect is called Coriolis effect. So you might have heard this Coriolis effect in geography. So Coriolis effect will actually move the projectile or the bullet sideways. This is called the sideways motion. So you try to launch something here. If you look from the top, let's say looking from the top. So if you try to hit someone here, your actual trajectory will be here, or maybe other way around also, depending on the how Earth is moving. So such effect is called Coriolis effect, and the missile will follow the Coriolis. I mean, it will of course get affected by the Coriolis effect for sure. So when we talk about the launch of satellites, launch of plane, then there we take care of the Coriolis effect. So if this is done by the NASA or by the ISRO or by other space agency across the world, then definitely they will talk about the Coriolis effect. They have to consider the Coriolis effect. But as a student of JEE, I mean, as an aspirant of JEE, mains, advanced, or whatever, that effect, as of now, we are going to ignore. Of course, you will learn about Coriolis effect in a chapter of rotational dynamics, not now. Or maybe in, sorry, circular motion also. Yeah, there also we are going to study about the Coriolis effect. So you'll get a brief introduction of Coriolis effect. So the third thing that we ignore is, what we ignore? Effect of Earth's rotation. So this is something which we ignore for sure. And based on this assumption, we are going to deal with motion under gravity. So basically, gravity is a force. Okay, so you can say motion under constant force. So gravity is, because it's a very famous force. So instead of saying that motion under the force of gravity, we simply say motion under gravity. What we need to understand is, it is a motion under force of gravity, correct? What we are saying here? What we are saying here?
Motion.
Motion
under
under
gravity.
force of gravity.
We are saying motion under gravity. Basically, it is motion under force of gravity. And we say a statement like this only when other forces are not playing any role here. The moment I introduce the air resistance, the moment I introduce some other forces into picture, it won't be called motion under gravity. Okay. But there are various motion in nature which can be replicated. It can be understood in the basis of motion under gravity. The reason is, the gravity represents uniform force field region, which means you are actually talking about motion under a constant force field space. So no matter where you go, the force which you will experience is constant, not only in value, but also in direction. So for the small distance journey, up to a few kilometers, we can say small. Tell me guys, what is the direction of gravitational force with respect to Earth's surface?
Towards the Earth.
Towards the
Earth.
Earth's center, right? Towards the center of Earth, you can say, or simply vertically downward. Can we say vertically downward? Can we say vertically downward? Yes or no?
Yes, sir.
So because it's a very small, let's say if I draw a tangent, which is a tiny tangent. So the tiniest tangent, if I draw here, this will represent a few 100 kilometers. Can you believe this? Few 100 kilometers. How? So how much is 1 degree? Have you seen 1 degree? Anyone? So if you have a D, the 1 degree is something like this. I think very small, like this. Is this the right depiction of 1 degree? Will you agree?
Yes, sir.
Okay. So 1 degree means how many radian? Pi by 180 radian. Okay. And in any triangle, in any arc, we know this already. In case of arc, what is the relationship between angle, radius, and arc length? Theta equals to L by R, yes or no? So L equals to how much? So let's try to understand how much is 1 degree equivalent of arc length. Okay, so theta is pi by 180 degree, simply 180, not degree. And Earth radius is 6,400 kilometer. Can somebody calculate and tell me how many kilometer it is? Anyone? Please do calculate and let me know. I am really poor at math, as you know. How much you're getting?
Sir, 111.644.
So roughly it is 112 kilometers, right?
Yeah.
So in our day-to-day life, do we throw something so far?
No.
Do we really throw so far?
No, sir.
No.
How far we throw? Up to few meters. So the distance which you travel, can we assume that that entire surface is almost flat? Yes or no? So for the distance that we actually practically, face or deal with, for that distance, the Earth can be assumed as perfectly flat. Yes or no?
Yes.
And that's why the term horizontal came into picture. So we use the word horizontal surface. So in our real life, we never face the Earth curvature unless we are launching a satellite or a rocket. In that case, you will see the curvature, the effect of Earth curvature. Okay. So now you know why we don't see the other end of ocean, because it is bending. Earth is bending, so you never see the horizon. The horizon is, bent on other direction. So that's why we see all the coastlines. I mean, you can say we don't see any coastline basically. So we don't see any the end of ocean. So if you are at Juhu Beach, you don't see the other end. Do you see it? If you see, then okay, you are having exceptional eyes. Okay, understood? So the term horizontal, the term uniform gravity, you can always replace by anything uniform in nature. So what we are going to learn is called motion under gravity. What we are going to learn actually is called motion under uniform force field region. Right now the force is gravity, but later on, as we will move from 11th to 12th, we can replace gravity by some other force, maybe electrostatic force. So what you need to know that the idea which will govern gravity, the same idea will also govern the uniform electric force field also. So moving under gravity is similar to moving under any constant force field system. It is not just gravity. Gravity is one of the famous example that we deal with. But again, I'm saying what gravity is going to do here, that a similar thing will happen in a chapter of electrostatics in class 12. So you have to wait for almost 1 year to go there. Next. So because we are going to deal with the horizon. So you have the predefined horizon. So you as a person looks really tiny. And if you throw something from here, you can throw this way, you can throw this way, you can throw this way. So the word motion under gravity can be both, either vertically upward or maybe at an angle. What is the difference between these two directions? If you throw something exactly vertically upward, the path followed by the particle will be one dimension or two dimension. Tell me, guys. If
One
I throw
dimension.
something like this, the path will be one dimension or two dimension.
One dimension.
One dimension. But the moment you throw other than vertical, the path becomes
2D.
two dimension. See, both are projectile motion, but because of the way literature is written, this is called motion under gravity topic. This is your motion under gravity. But for some reason, I don't know how literature has developed over the time, but people call this motion as projectile motion. They don't call motion under gravity. So the moment you go from one dimension to two dimension, you start calling as projectile. But if you throw exactly vertically upward, then it is called motion under gravity. So this is a small difference that you need to recall or remember. So in projectile motion, it is necessary that the motion must be two dimensional. But in motion under gravity, we throw exactly in the vertical line, either you throw up or down, but you must throw in the vertical direction. And if the motion remains straight line, we call motion under gravity. If you throw obliquely with respect to vertical, the moment you deviate from the vertical, then the motion is called which motion? Projectile motion. Okay. So both are similar in one aspect. The vertical motion of this particle and the vertical motion of this particle will follow the same principle, same formula, same kinematical equation. The only difference is, in this case, we have to also discuss and deal with the horizontal motion. So this particle will have two components, vertical and horizontal, and therefore we need to deal with two mutually perpendicular components to get the complete motion. But the way we are going to analyze the vertical motion will be similar to the motion under gravity. So once you understand the motion under gravity, you actually understand half of the projectile motion. Why only I'm saying half? Because I need to discuss the other direction of motion explicitly. So that is the basic difference between the motion under gravity chapter and projectile motion chapter. That's the only difference. Okay. Numerically, there is no difference. Formula wise, there is no difference. We can always convert one formula into other formula. Okay. So you just need to know the something called component. Now, no matter where you go, whether you go up, whether you are stationary, you are moving down, how gravity will act on you, how the Mother Earth will attract you towards its center or away from the center. So if you throw something, and it really doesn't matter how you throw, whether you throw upward, downward, or at an angle. Let me show you all the cases. If I throw like this, 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 tell me in each case, how gravity will act? Tell me guys, how gravity will act?
Vertically down.
Only downward. Can we have upward gravity?
No.
Simple, because Earth will attract downward, so it will only act downward. If the force is downward, what will be the direction of acceleration?
Downward.
So you must remember that acceleration due to gravity is only downward. Okay, there is no other direction. So now this is confusing. I'm going to use G vector to represent the gravitational acceleration due to gravity in vector form. Now this G with arrow is not same as the G without arrow. So when I use G with arrow, I actually talk about the field called gravitational field. I talk about the acceleration due to gravity. I talk about something called gravitational field intensity. But when I use a simple G, then I actually talk about the number 9.8. So a G without arrow is actually representing a number which is called 9.8. And in most of the chapter of motion and gravity as well as projectile motion, we prefer using G instead of writing 9.8 because it's not convenient. But when I'm writing G with an arrow, I'm not talking about the value. I'm talking about the vector called acceleration vector. I'm talking about the acceleration vector. So G with arrow is entirely different from G without arrow, because the usage is so common that even I'm bound to use the same symbol. And so it creates confusion. So what G with arrow represents, guys? Acceleration vector. And what G represents? A number called 9.8 meter per second square. You can simply say this is the value of G. But this G vector is acceleration vector. So how to represent a G vector? If I want to express in terms of I and J, let's say if I choose vertically upward as y-axis. So if I assign some coordinate system, how the G vector is acting, tell me.
Minus JK.
So the value of G is how much? The value of G vector is G. And what is the direction? Direction is minus J cap. Understood? Hello guys, am I audible?
Yes, sir.
So G vector, how we write? Minus GJ cap. Okay. Is this clear? Yes or no? Everyone. Siddhant, Prashansa, Rugved, tell
Yes,
me
sir.
guys. I
Yes,
think
sir.
they have gone, they have to go. Are you going, Rugved?
Yes, sir, in a few minutes.
Oh, okay. And I think Prashansa will also go today. So G vector, we write as minus GJ cap. Now let me tell you something really interesting. The moment we talk about one dimension motion, whether it's a horizontal or vertical or at any direction, in any direction, in one dimension, we prefer not to write I, J, K or arrow, because it is understood that in one dimension, we have to deal with just two directions, either right or left, up or down, this way or opposite way. So the moment you deal with one dimension motion, the possibility of motion is only two. And therefore, we prefer, now this is like preference, this is like a matter of convenience. We prefer not to write the arrow or vector sign. It doesn't mean one dimension is not the vector equation. Okay, one dimension is also a vector equation. Because of the fixed possibility, what we do, instead of plus I, plus J plus K minus K, we prefer choosing one direction as positive direction and then other we call negative direction. Now, this is the matter of choice. So these are vector quantities which you deal with, but in one dimension, it is the matter of preference that we do not take the plus, or we do not take the vectors notation. Rather, we switch to the plus minus notation. And therefore, again, when I talk about the vertical motion, again, it's a matter of choice. So if I choose upward as positive, then I must choose downward as negative. But can we make the opposite assumption? The answer is yes, of course you can. And no one is going to stop you. Because no one can force you to draw y-axis upward. You can draw y-axis downward. Okay. It's a matter of choice, matter of convenience. So I can, if I choose downward as positive direction, then upward must be negative. The choice of assumption will never affect the final answer, but it will certainly affect the way you write, the way you express. But at the end of the solution, all answer turns out to be same, no matter with what assumption you start with. So always remember, one dimension, we ignore the vector notation and we take care of the directional issue with plus minus convention. And again, the plus minus is not a forced thing. It is a matter of choice. You all are free to choose the way you want. The only rule is, the moment you make one assumption, stick to it throughout the problem statement. Till you solve that question, you will never change in between. So once you start with one assumption, continue till you get the final answer. Is this clear, guys? Yes or no?
Yes, sir.
So G always acts vertically downward. Any doubt in this? The direction
sir.
of G, will depend on motion of the object. Yes or no? Direction of G will depend on motion of particle. Yes or no?
No.
Correct. Very good. It really doesn't matter how the particle is moving. Gravity will do its job. It will act downward because it will attract you. Okay. So G is called acceleration, and that is why acceleration will change the velocity. So once you begin with the velocity v, or any value, you can name it u, v naught, or whatever you would like to write, gravity will change it. Now the question is, which component gravity can affect? Once you know the direction of acceleration, although it's a part of projectile motion, but we can discuss here a bit. Since we know gravity will act this way, and let's say someone is throwing the object this way with some velocity v, and let's say this makes some angle theta. So every vector we can resolve into two mutually perpendicular component at least. I mean, of course, we can come and resolve into infinite component, but two mutually perpendicular component is sufficient to get back the same vector. So can we convert this v vector into two component, one component which I can take exactly parallel to the vertical direction? So what will be this value if I take the component of v? Any guess?
V sin theta.
Excellent. And what about this one?
V cos theta.
Now, which component gravity can affect?
V sin theta.
Only the component in its direction. So gravity can only affect or change this component. Gravity has no role to play to affect this at all. So now if you look at this component and gravity, are they supporting or opposing?
Opposite.
So as you go up, you will slow down or will speed up?
Slow down.
So if you are slowing down, will you stop somewhere? Yes or no?
Yes.
If something is slowing down, it will stop at least at some height. Correct? Will you stop? Yes or no?
Yes.
So once you stop, that is called the maximum height. That is called the maximum height. Understood? So who will tell me what should be the definition? Now this is the guess point. Can you guess what should be the definition of maximum height? So at maximum height, what will happen? Which component will become zero? This one or this one? Or both?
Only vertical component will become 0.
Only?
Vertical component will become 0.
Yeah. Very good. So if someone will ask you to define the definition, I mean, give the definition of maximum height, what should be the correct definition? So what is maximum height, guys? So what exactly happens at maximum height?
The vertical component of velocity becomes 0.
Excellent. Maximum height doesn't mean velocity is 0. Maximum height means the height at which vertical component of velocity is 0 is called maximum height. That is the definition. Is this clear? Is this clear, guys?
Yes, sir.
So if someone will ask you in this chapter anything, you have to think about the correct definition which can lead to that answer. So is it necessary that at maximum height velocity must be 0? Is it necessary at maximum height velocity must be 0?
No.
No, sir.
What is necessary?
Vertical component of velocity must be 0.
Very good. It is the vertical component which will decide the maximum height, because see, who will take you upward is the vertical component. The horizontal will only do the horizontal motion. So your upward journey is governed by your upward component, and gravity is playing the spoil spot. It is reducing it. Okay. So after some time, what will happen? You have to stop in the vertical direction. You may continue in the horizontal direction. So when you study the projectile motion at maximum height, the vertical will be 0, but you will have the horizontal, because horizontal gravity never affects, so it will remain same everywhere. But in motion under gravity, at maximum height, the velocity itself will be 0, because we have only vertical component. We don't have horizontal component. Yes or no? In case of motion under gravity, at maximum height, can we say velocity will be 0?
Yes.
Because fortunately or unfortunately, we don't have horizontal component. We only have the vertical component, which is the total velocity. Do you realize this? Tell me, guys, everyone.
Yes, sir.
So in motion under gravity problem, can we say at maximum height velocity will be 0? Can we say?
Yes.
But in case of projectile motion, can we say at maximum height velocity is 0?
No.
No, sir.
No.
No.
There we have to specifically mention the vertical component. In case of motion under gravity, that condition is not required. You can either say the vertical component is 0, or you can say the velocity is 0. Both means the same because of the way you're throwing. Is this clear?
Yes.
Now, something very interesting you need to understand, that in the kinematical equation, every term is detached from each other. What does it mean? So when you write v equals to u plus at, or when you write s equals to ut plus half at square, what you need to really understand that ut is doing its own job, and the plus is saying that you're superimposing that effect with half AT square, which is a separate job. So UT and half AT square is two distinct job, two distinct role played by two distinct quantities. And a plus is representing superposition of these two effects. Now, luckily, in physics, we talk about superposition only. But in one dimension, that superposition turns into a mathematical addition. That is a fortunate gift. So UT plus half AT square, if you're writing in one dimension, it is addition. But in vector form, it is superposition. And as we know, in one dimension, the rules of vector algebra and the rules of simple algebra both coincides. Do you remember this from vector chapter? So if two vectors are in the same direction, the resultant will be sum of the vector magnitude, yes or no?
Yes.
If 10 Newton is right and if 5 Newton is also right, the net will be how much? 50 Newton, right? Now this is only possible for which case? One dimension. But in general, if we have 10 Newton and if we have 5 Newton, can we say both is 15? Can we say this has 15, yes or no?
No.
This is not 15, which means the moment to switch from one dimension to 2 dimension or 3 dimension, the vector rule will be followed. In one dimension, whether you follow the vector rule or you follow the scalar rule, both are same. And that is why we fail to see the vector idea of superposition when we deal with the problem of kinematics, or when we deal with the problem of one dimension, or when we solve question of kinematical equation. What is really interesting to know that UT is a separate entity and half AT square is a separate entity, and both are playing together. And what you see is the resultant, the superimposed result actually. So it is matter of interpretation. You can interpret the way you want. So this chapter is pretty easy if you just understand this interpretation. It's pretty easy. Now, since we are going to talk about the motion and the gravity, so how the kinematical equation will look like if we interpret accordingly. So for interpretation, I'm going to take vertical as upward as positive. So everything having direction below, direction will be taken as negative. So I'll stick to the Cartesian coordinate system. So I'll take, you can call this as y-axis. And you can take the horizontal as, so I'm taking horizon as x-axis, and this is vertically upward as a y-axis. Okay. And we know that our gravity will be like this, or you can show it like this. It doesn't matter. Gravity direction is always downward. Okay. So what is the actual equation? The first equation is V equals to U plus AT. This is a vector equation. It's the first kinematical equation in vector form. Okay. In one dimension, what we are going to do? Okay, in one dimension, we remove the arrow first of all. We just remove the arrow. So what we write? V, U. But we are talking about the motion and gravity, so the A can be replaced by which symbol?
G.
Plus G or minus G?
Negative G.
Simple. This is your question. The next is displacement equals to, which was delta r, ut plus means vector addition half at square. In this case, how we can write? Or you can write, okay, one more step. I can also write this as v vector equals to u vector plus g vector into t. So this equation represents what? Anyone remember this? We have discussed this already. Triangle law. This is the resultant of these two vectors. Do you realize this? The v represents the resultant of u and gt,
Yes.
and t is a scalar. T is a scalar, right? Time is scalar. The word scalar means which which scales the value with which you multiply it. So t will scale the value of g, which means if t will grow, the g vector with t will scale up anywhere. So those who have missed this, you can go and watch the vector once again. You'll come to. How to write the equation with g into picture? Ut plus. Can we replace a with g vector? Yes or no?
Yes.
See, I'm just writing g vector. See, I haven't put the value. When I put the value, I have to choose plus minus. So far, this is the vector notation. So we have to only stick the positive. But the moment you convert it into one dimension, how you write? You write because you are talking about the vertical motion. The way of writing should be that you all must follow the definition of displacement, which you all forget every time. It is change in position vector. So first of all, you replace delta r by y minus y naught. Y minus y naught. What does it mean? Change of so y is called position vector. It's a y coordinate of the particle with respect to the chosen coordinate system which you have taken here. So this is y. What is y naught? Y naught is called the initial position, which need not to be origin. It could be here also. Yes or no? So this is called position at 0. This is called position at any time t. So the delta we write as y minus y naught. Okay. Now, how to write ut? You can write ut as simply ut. Now, depending on whether you're throwing up or down, when you substitute the value, the plus minus should be taken care of. Because u is unknown as of now. That's why I cannot put plus or minus. So when you actually solve the problem, you can decide to put a u as positive or u as negative. Okay. Plus plus. But g is well defined. G is well known to us. Can we write this as g as minus g? Tell me, guys, can we write like this?
Yes.
So your equation will be y minus y naught equals to. And you can also write this as UIT. That's a nice way of writing. UIT. So the better way of writing is like this. So y minus y naught equals to UIT, which means we're talking about the y component, and then half AYT square, which means we're talking about the y component of acceleration. And now further you can substitute. I mean, I should have written this step after this. Let me remove this. See, in one dimension, this is the formula that you should use. Don't use the old formula which you have the habit of writing. S equals to ut plus half t square. In difficult or challenging problem, this way of writing will always give you the answer without any manipulation. Just use the formula, substitute the value. You're bound to get the answer. Okay, so when you solve the question, you can write like this. The way of writing is always think the formula as ut plus half t square, but value substituting the value, you can write like this. So in motion the gravity, you can use this formula. Just is this clear, guys?
Yes, sir.
Yes, sir.
And the last question. Okay, this is also called displacement triangle. And again, if you have forgotten, you can go back to vector chapter. You can reread about this in triangle law chapter. Okay. And the last is what? V square equals to U square plus 2AS. But how actually we should write here in vertical direction? You can write as VY square the moment you change from the old way of writing to this new way of writing, then every problem requires similar effort. So you can solve any question if you just use the formula and proceed as per the meaning of symbol. So once we start solving problem, these things will become easy for you. So let's start it, because these are the three formula which you need to know. And the fourth one is what? Okay, u plus v by 2 into t. So how to convert this into vertical motion formula? Tell me, guys. Now this time you can try. How to write it here?
Y minus y naught equals to uy plus vy divided by 2 into t.
Excellent. Correct. That's the right answer. So let me show you. You can derive any formula if you know how to write these things. That's it. So let me show you quickly. You can finish this topic in next 1 hour. No, do we have time? Yeah, we have time. We have 1 hour, yes. Okay. So in vertical motion, how we throw? So we throw something either vertically up or vertically down. So to throw something vertically down, we have to go to some height. But to throw vertically up, you can throw from any height, right? So imagine this is the ground. What is the meaning of throw? How you throw any object? Have you realized this? Anyone? So who will explain how you throw? So we have some senior citizen in this group. Someone can
Can you
explain.
repeat?
Yeah. Explain how you throw something.
So like in the upward direction.
Not any direction. Like how you throw simply. You want to throw a ball to your friend. How you will throw? Explain in terms of physics.
Moving movement of hand towards the
Friend.
friend. Yeah.
So you hold the ball first.
Yeah.
Then you displace the ball using your hand.
Hmm.
You apply force.
Yeah. For some. Yeah.
So when you apply force and you displace, what you do some work.
Yeah. What?
When you work, then you give energy,
Yeah.
and then you
Mhm.
release the ball.
Yes.
And the energy which you give appear as kinetic energy to the ball.
Yeah. Kinetic energy. is- Mhm.
And with that kinetic energy, the ball travels forward.
Hmm.
And because of gravity, it bends towards the earth
Towards.
or comes down, right?
Yeah.
Eventually.
Yes.
So throwing something is the object which you throw, first it remains in contact with your hand. So while you throw something, can we say that motion is motion under gravity? Yes or no? Now the students will tell me. When you throw something, before you have thrown, can we say the motion of the ball while in hand as motion under gravity? Yes or no? Is my question clear to all of you or not? Is
So
my
please
question
repeat.
clear?
So repeat.
What I'm saying is you take a ball while the ball is still in contact with your hand. You haven't released it. Can we say the motion of the ball as motion under gravity? Yes or no?
Ball is still in the hand. No?
Yeah, you're about to release.
Yes.
Yes.
So can we call this as motion under gravity?
Yeah.
The answer is no. Because the ball is experiencing two force, one due to gravity, other due to your hand. So is it motion under only gravity?
No, sir.
No. Then
It is motion under two forces, one by your hand, other by gravity. So should we consider such force, such motion into this topic? Yes or no?
no.
No. So our motion will only begin when the ball is released from your hand. It is only under gravity. Understood?
Yeah.
So let's say you take a ball attached to a string and you wield the string. And then you release the string. So while you are wielding the string, can we say motion under gravity? Yes or no? You may be wielding in the vertical plane. You may be like, taking the ball and taking the rope and you're turning like this with your free hand. So can we say this is motion under gravity?
No.
No. Because this is the motion under gravity and the tension force of the string.
Yeah. Tension will come. Yes.
Because the rope will have some tension. Yes or no?
Yes.
Yes, sir.
So when I say motion under gravity, actually I talk about only gravity. If anything is interfering with my motion, then I cannot use this relationship. I cannot use the motion under gravity formula or kinematical equation. No. Because that is not motion under gravity. That is motion under gravity and the thread. The tension developed by the thread. Is this clear, guys? What I just said?
Yes.
Okay. So when you are throwing the ball, the motion will be considered only when it is leaving the hand of the thrower
Yes. Leaving the hand. Yes.
or leaving the thrower. It should be free from any contact. It should be free from any what?
Contact.
Contact.
Contact force. Yeah.
So if you throw a ball, the moment it has left the earth's surface, the moment it is slightly above, then the motion begins. When the motion will terminate? When the motion will terminate?
When it reaches the ground.
After touching the ground or before, just before touching the ground? Just before touching or after touching?
After.
Sir, after.
Come on, guys. Once it will touch it, how you can call that as motion under gravity? So what is the meaning of motion under gravity? Free from any contact. Understood.
So what you said, motion under gravity will terminate once it
Terminate.
Yeah,
touches.
yeah. So that's why I say motion under gravity, gravity will terminate because once you touch it,
Hmm.
it is not motion gravity. So just before touching, we will consider motion under gravity. That is the meaning actually. Maybe the interpretation is not correct. What I mean to say, up to what instant we can call that as motion under gravity? Yeah, you can think that way. So the instant after leaving and the instant just before touching is called motion gravity. Just before touching. After that, there is no motion gravity. That's called collision actually, which you study in a separate topic. So what is the meaning of motion gravity? The motion free from any contact forces. Once again, the motion free from any.
Contact, sir.
So
Contact force.
when we solve question, so we consider motion only after contact is lost and before the contact is about to be made. Just before you are going to make the new contact. Till that duration we call motion under gravity. I hope this is clear.
Yes, sir.
Yes.
So just before the contact, the ball will, if I throw something with a velocity, let's say V0, in the vertical direction, just before you're about to hit the surface, what will be the speed?
V0.
But in which direction?
Opposite direction.
How many of you realize this? That the velocity will be opposite direction and same as initial value. Because you're coming back to same level, that's why the answer will be same, right?
Yes.
Because there is no air resistance, so there is no drag force, so there is no kind of resistance, there is no loss of energy. So when you throw something with V0, and when that comes back to the same level, it must have the V0, but in opposite direction. So can we say the ball will have same initial and final velocity?
Yes. No, but in opposite direction.
So can we say, that's the question, can we say the ball will have same initial and final velocity? Can we say the ball will have same initial and final velocity? Yes or no?
No.
We cannot say because velocity is vector quantity and direction does matter. Is this clear?
Yes.
So basically you can say final velocity is opposite of the initial velocity. Yes or no? So if I choose initial as positive, then final will be?
Negative.
Or vice versa. If I choose final as positive, initial will be negative. It depends on your assumption. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So the question is, if you throw any object, and we always consider the scenario when object has left the surface. The contact is not there. So that's why I have shown some gap. So when you throw something with some initial velocity, of course, to throw, you have to impart some initial velocity. Now, there are two conventions which is very famous, and you all can decide together that which convention you want to go through. So there is a British convention which uses U, V, and all. And there's the American conversion, which is more meaningful to me, that they will use not U, they will use V0, which means V at 0 or initial. So they write V as V, but they write U as V naught. So which one you want to go with, British or American? And I will not use Russian because that's really bad. Tell me, guys. So you want to go with UV symbol, U plus V equals to U plus AT, or the V naught? V naught means initial value.
So V naught.
Okay, let's vote. So V naught versus U. So those who want to, let me open this first. So raise the hand for a V naught. Siddhant, you said V naught. You haven't.
No, sir, I
raised
changed my
hand.
mind. You knows.
Okay, you only. So for you, raise your hand for you. Raise hand for you. Okay, great. Okay, so I'll go with you. American rejected. So Rishi Sunak accepted. Eh? Oh, that's why.
Yes.
Now England is like in. Oh, I got it now. Yeah. Now you think that England is like New India. Anyway, so let's go with British. You. So you throw something with initial velocity u. Okay. So what will happen? It will go up. But gravity will slow down. Yes or no? So eventually it will come to rest. Okay, it will come to rest. So at this instant, what is the velocity here? So as I said, in case of a motion under gravity, we can use the word velocity also. So at maximum height, what happens? Velocity becomes 0. And the value of acceleration you can call G. And the arrow is representing downward direction. So I'm just writing G with the downward arrow. Okay. And then it will not stop there. So for how long it will stop there? So will it stop there for some time or will it stop there momentarily?
Moment.
Movement.
Yeah, it will stop there momentarily. And then we'll start the which journey?
Downward motion.
Downward.
So while going upward, the gravity was opposing. But while coming downward, gravity is going to support, yes or no?
Support.
Yes.
Yes.
So while coming down, the motion will be accelerated or retarded.
Accelerated.
But while coming up, while going up,
Retarded.
so the question is, what we consider accelerated or retarded, because it is performing both kind of motion. What we should consider, accelerated or retarded, or both? That's the question. Tell me, guys. Is it accelerated motion or retarded motion?
Sir, when it goes up,
No, for the entire journey.
Sir, both of them are okay.
Both. Okay, so that was the confusion for most of us, and that's why this question was asked. The answer is your consideration about acceleration or retardation should be with respect to initial velocity, not what happens afterwards. Once again, your consideration of acceleration or retardation should be with respect to initial velocity, not what happens during the motion. Is this clear?
Yes.
Now, what will your answer? Is this motion retarded or accelerated?
Retarded.
Exactly. This motion is retarded. And you need not to worry about what happens during the journey. That is not our concern. Okay. So the acceleration or retardation is always seen with respect to the initial velocity, not what happens during the motion. If you want to make a point of it, you can write it down. Or if you want me to write, I'll write it. Should I mention this in notes?
Yes, sir.
So what should I write here? You tell me, I'll write. Siddhant, tell me, what should I write here? Tell me, you tell me, I'll write it. If you all have understood, you can tell me. Who will tell? Who will tell? So whether the, okay, no one will tell you, whether the motion is accelerated or retarded is decided with respect to initial velocity, not what happens during the journey. I hope this is clear to all of you.
Yes, sir.
Okay. So there are a variety of questions that we'll ask. So what will happen? It will stop momentarily. So it means there's no relaxation period. It will just come to rest and it will come down. So it will start coming back on the same path. But it is convenient to represent the same path by drawing another line on sideways. And as I said, it is about to hit the surface. It has not hit the surface, right? So when you come back to the same level, your velocity will be downward, right? So the first question that they will ask you, calculation of time of flight. Calculation of time of flight, which we represent by capital T. And before we derive it, we should define it. So tell me, guys, what should be the definition of time of flight? What is time of flight? Right?
Total time which the body is performing a motion under gravity.
Yeah, so you can say that it is a time for which the object is airborne. Very simple. What we say? It is a time interval for which the object is airborne. Basically, it is airborne means you are saying it is not in contact. That's the meaning actually. So I hope this is clear.
Yes.
sir.
Okay, now to get any answer in projectile motion or motion and gravity, we need to look for the situation, and using the kinematical equation, we have to derive the answer. So technically, don't try to mug up any formula. Just you apply basic kinematical equation, which because you have just 3 equations. So out of the 3 equations, which equation will have time as a variable? All 3 or only few of them? So time will appear in which of the formulas?
V
One.
plus it.
So there how many formula I have given you? I think I have given 4 formulas, right? So
Yeah.
can you check in how many formula T appears? Can you go back and check?
Sir, and 2 of them.
The first formula was V equals to E plus AT. Second was, okay, let me write down the simple one. You can say Vy. Okay, it's a good practice to write like this, although it's cumbersome, but as a beginner, I will encourage you to write like this. The next was the third was so this last formula is mostly ignored, but this is very important. It solves the question really fast. Now, if you want to solve the question using Cartesian system, again, after some expertise, we can do all this mentally. But as a beginner, when we start learning, we have the inertia that we carry from the class 9th. So it is difficult, first of all, to switch to this new way of writing. I know that you all will have a lot of resistance towards this way of writing. Many will not accept. Only when they will get stuck in tough question, they will ask me doubt. Then when I will solve using this same formula, they will realize that, okay, this is the right way. So as a beginner, even I had that resistance. I mean, I was thinking, okay, why I'm going to write such a notorious, symbolic notation? Why not? We can write down the simple one. But the fun fact is, when you solve actually problem, you're not supposed to write these things. You're supposed to substitute the value, and the formula will be in your mind only. So it will float in your brain, and on paper you're going to only write the values. Okay, so you're not supposed to write the formula. You're supposed to write the values, but in your brain, these things must float actually. All right. So how to get the answer? That's a simple question. So if you want to use the Cartesian system, we have to start with some origin, some y-axis. We have to name it, and then only we can solve it. So the first difficulty that you may face is the choice of origin. You may get confused that where should we should take the origin, and the simple answer is anywhere. It really doesn't matter. But a proper choice will make it easier. If you make some random choice, it will become slightly difficult. So as a thumb rule, what I will say to all of you, take the point of projection. Take the point of projection as origin. So take point of projection I hope this part is clear.
Yes. And
the next part is draw the coordinate axis. It is logical because you are talking about the motion and gravity. You must choose one of the axes vertically upward. So I will take this as origin and this as my y-axis. And you will see why I'm doing all this thing. Although I can solve, I mean, you can also solve with very, ease with the old formula. But since we are moving towards slightly more difficult scenario, and we are going to face something more difficult in coming times, this habit will make things easier for you. If you also want to continue with the resistance, then I cannot do much. You will face the difficulty and maybe later on you will realize this, but it's good to practice this way. Okay. So can we solve using all formula or can we solve using only one of them? So let's try to derive a formula using the equation A. Because T is there, so hopefully we can get. So using A. So in the A, I want to find the time of flight. Okay. What are the information known to you in advance before you have solved anything? What you can see and say? Tell me, guys. What you can see and say? Am I audible?
Yes, sir.
Are you guys listening what I'm saying? So what you can see and say, what you see here. So if I ask you, out of all the variables in the first formula, what are the values which is known to you? So you have 4 variables, 1, 2, 3, 4. But all cannot be variable. Some must be known to you in advance. Only one should be variable. So can we get the answer using this formula? Do you know Vy, by the way? So at the end of the journey, what is Vy? Do you know it? Yes or no?
Yes.
So what is Vy here?
Minus U.
Very good. Excellent. So what is Uy, by the way?
Plus U.
What is Ay?
Minus G.
Oh, so you know everything.
Yes.
So you can substitute, no? Tell me the answer. So remove small t by capital T because these answers are for the end of journey, right? After capital time T. So what A implies? What we should add here? Minus U equals to plus U plus minus G into capital T. Yes or no?
Yes, sir.
So can you rearrange to get T? How much you are getting T?
2U by G.
That's simple. This is the answer. This is the time of flight. It is 2U by G. Is it really difficult? No. Now, can you think of solving the same question using the second equation? Because I can see T there also. And that is the part which you have to really practice right now. So whatever time it may take, I'm not going to worry about it. You can take 1 hour, but you have to solve using B and C part. Just play with the formula. The moment you will realize, you will understand this chapter fully. Only one question is sufficient to understand the chapter. Okay, guys. So I'm giving you all the time you have. So before I will end today's lecture, you have to solve B and C. If you solve early, I can teach you something more. If not, keep on struggling. Keep on hustle. All right. Tell me once you get the answer. So solve using B formula, solve using C formula. And also if you can think of something more, you're free to choose and solve. If you will come up with more than 2 solutions, because we have 2 formulas, so 2 solutions anyway, you'll get some gift. And if you come up with 4 more methods, you get some double gift.
So like we have to use B separately and C separately, or we can combine both.
Okay. So you can also use the concept of time of ascent and time of descent, because you know at maximum height velocity is 0. And therefore, you know the initial velocity, you know the final velocity, you can find the time of ascent. Okay. So let's calculate the time of ascent first. For sure, this is going to be half of the time of flight, but let's calculate the time of ascent using the information known to you. So what do you know? You know the V. So at t equals to 0, you know the velocity, initial velocity. And at t equals to time of ascent, what is the velocity, guys? At t equals to time of ascent, velocity is 0. So we can use the first kinematical equation to get the answer directly, right?
Yeah.
So Vy equals to Uy plus Ay into T. 0 equals to U minus G into TA, right? So time of ascent is how much? So can we say time of flight is twice of time of ascent? Because the time of ascent is same as time of descent, because you are coming back to same level, right? So while going up, gravity will retard you, and while coming down, it will accelerate you. So the time taken will be same. Okay. It is clear.
Yes.
So the time of flight is how much? Twice of time of ascent. Okay. So can we think of some other method? Method number, I don't know. Okay, you have solved 3. The 5th method. Now, 5th method is basically based on the common sense. So you can use the direct formula. You know, this is S equals to UT plus half AT square. In gravity, you can write as this way of writing, which is let me tell you what is happening. So this is the method which I teach to class 9 students, because they enjoy a lot. So let's see if you can also enjoy. So what I say that, imagine there is no gravity. Imagine there is no gravity, and if you ignore the gravity for some time mentally. So in time of, let's call T is the time of flight. Hypothetically, let's call T is the time of flight. If I switch off the gravity, and if I throw something with velocity U, in time of flight T, how much will move? If there is no gravity, will you move uniformly or non-uniformly? Tell me.
Uniformly.
Uniformly, right? Because gravity is not there, so you will not decelerate. So whatever velocity you will impart, that will continue forever. Yes or no?
Yes, sir.
So in time t, capital T, how much will travel upward? Since bottom. In time t, how much will travel, guys? Tell me. The displacement will be how much? Tell me, come on. In time capital T, how much will travel upward?
Sir, UT.
U. What happened, guys? For uniform motion, can we write displacement as UT? Yes or no?
Yes.
But actually, the ball should have been at the bottom, no? Yes or no? So if there is no gravity, the ball would have gone up by UT. But after one time of flight, what we know? That it is actually at the bottom, back to bottom, yes or no? Tell me, guys, yes or no?
Yes.
So who will bring this bottom back to bottom? So we know that gravity, look at this part. This is called the displacement due to gravity. This is the displacement due to the initial velocity in the same time t. So in capital time t, if u will take you up by ut, gravity will bring you down by half gt square. And because you are back to the same level, so this quantity must be same as this quantity, yes or no? Can we say?
Yes.
So ut must be equals to half gt square. Because I said in the very beginning, both are working independently. What you see is the resultant, what you see is the net effect, but you can also, analyze the thing in a discrete manner. Like you can take one effect at a time, then see what is happening, and then superimpose the second effect to get the net effect. And this way of solving is also very fast. So you can solve this question now. T is how much? See, simple answer. Is this clear to you guys? Tell me yes or no.
Yes.
Yes, sir.
So we know what a kind of effect we want to have. So the end condition is known to us. And that is why I know in time t, you will take you ut above. But you are supposed to be at the bottom. So the quantity which will bring back to bottom is the gravity. So it will give you, bring you down by half gt square. And because we know you are at the bottom, so ut and half gt square must be equal, then only it is possible, isn't it? I hope this is clear.
Yes, sir.
Yes, sir.
Okay, so this kind of activity will help you, calculating mentally. So sometimes you're not supposed to even use a pen, just think mentally, you'll get the answer. And this is also very powerful to solve even more challenging problem without any confusion. So you can think gravity as some secondary effect and initial velocity as some other effect. You can say primary effect. So there are two effects, and these two effects will work together to create the resultant effect. So that's why I say there is always principle of superposition in physics, and that is really a nice way to think about the analysis while doing the analysis of vectors, that they work as per the rule of superposition. What we see in reality is the mix of the two, so you don't see the individual effect. That's why you're confused. Okay. So this idea we can employ for the projectile motion also. We have done this in vector, if you remember, which you don't, I know, but still you can go back and start revising vector. It will benefit you again a lot. So you all will revise up to triangle law. Okay. So you do not need dot and cross, but go and revise up to triangle law, then leave the vector chapter. Before the work any power, revise up to dot again leave, and before the rotation, revise the cross and then leave. So that is how you have to keep on visiting vector again and again. It's not the end of the chapter is not over. You have to go back and visit, watch videos again. Keep every discussion in alive in your brain. Okay. So we got the time of flight with various formula. The idea is, see, if you tell me to derive something, what I'll do is I will never use, will never try to mug up any formula. So what I'll do is I'll try to first of all think of where that variable appears in a kinematic equation. Then the next step is search for the conditional values. Look, what you know in advance. Let's say you know initial, you know final, you know initial position, you know final position, you know something, either coordinate or the velocity value. Once you make a note of all these variables, it is only a matter of substitution. You substitute in the one of your known formula and you can get the answer. So congratulations to all of you. You all have done really great job by deriving the formula without mugging up anything. And if you have realized that the way of approaching problem of kinematics, just keep the same approach for any problem or every problem. Don't try to look for formula or something. If you look for formula, you will never be good with kinematics. If you look for the method, you will always be excellent in kinematics. Kinematics is again, it's not a chapter, it's like a puzzle, your aptitude, you develop your aptitude, thinking ability, and ability to manipulate things. And once you develop here, it will remain with you throughout the journey of JEE preparation. Okay. What else generally we look for in motion under gravity? If you have thrown something, so definitely you will wait for after how much time it will come back. What else you will look for?
How far?
So you will look for how far you can go up, above the ground. So you can always ask for the maximum height, right? So what is the maximum height attained, right? So tell me, guys, what should be the definition of maximum height? We have discussed this already. What is the definition of maximum height? So what happens at maximum height? We have discussed, I think.
Vertical component becomes 0 of velocity.
Correct.
Yes, sir.
So see, kinematics is all about definition. If you know the definition, derivation is a piece of cake, because definition will carry the information and you need to decode that. Okay. So in the very beginning of the first lecture, I said, okay, the way of learning is DDA. Do you remember DDA? What was D? The first D represents? Okay, no one remembers. Really bad. Really sad to know that none of you remember this. What was the first D representing? Siddhant. What is the first D representing here? Tell me. First D represents? Come on. Really sad. Definition. Second D. And third. So until you're not able to define something, you will never be able to derive the same. And if someone is not able to derive, you cannot apply it. So those who, depend upon the formula, they are like short life. Your self life is very small. So it will work for a few weeks and you will forget everything. And then in the actual examination, which will come after 1.5 years of rigorous effort, by that time you will remember nothing because your process was incorrect. So you may perform in the weekly test, but you will never perform in the major test. Okay, so those who learn in that way, they always falter in the test which is having large portion. but they do really good in a small portion test because they mug up everything, so they apply quickly and they get the answer. So there is a different way to approach, physics. One is the long-term approach, other is the short-term approach. But JEE preparation is always long-term, so please never ever try to stick to some short-term approach. That approach itself is wrong. Okay. So you have to always think of what is the definition and how I can derive it using the definition. And if you know the derivation and definition, both application is piece of cake. Anyway, so what is maximum height again? Let me just formally put it here because now you know the answer. It is the height at which vertical component of velocity becomes 0. Any doubt in this?
No, sir.
So once you know that, definition, can you derive it? So you have thrown the object with initial velocity u. So what do you know? You know the initial velocity, that's it. And what else you know? At maximum height, the velocity is 0. So because you know these two information, which kinematical equation will give you the height? And again, there are many ways. And probably the kind of calculation which you have done before may help you. So maximum height is displacement for what interval of time since beginning? You have gone to the maximum height after traveling some displacement, right? Some distance. So for what interval you have been moving upward? And what we name it? Okay, I forgot to mention this. So this is nothing but the displacement during the time of ascent, yes or no?
Yes.
And because you know the time of ascent, so can you get the maximum height? Yes or no?
Yes.
Or because you know the u and you know the v, think of the kinematical equation which can relate uv with displacement. Which kinematical equation? 1, 2, 3, 4. Which one?
Third one.
Excellent. So you know the third one will help you. So can you use the third one and get the answer? Or also you can use TA and get the answer. So I want you to solve by both the methods. Using the third and using the TA method.
Sir, I have to leave now. I have class in 10 minutes.
Okay. So in fact, I will stop it. You can leave now. I'll just put the derivation and I'll end the lecture. So you
Okay,
can
sir.
watch the last 5-10 minutes. Okay. I think Harry, you also have to leave, right?
No, sir, I'm comfortable.
Okay. Okay. So what we can do here? Use the third equation. Tell me the answer.
Sir, it is u square by 2g.
Correct. Very good. Yeah, sure, I can also leave. So we can use the formula v square equals to u square plus.
Mhm.
We know this is 0, this is u square.
Yeah.
This is minus g. And the y minus y naught is basically y naught is 0, so this is h max. So the answer here is h max equals to
U square by 2.
so basically it's a vertical component velocity square by 2g. It's not u, it's a vertical component which we should remember this way. The uy square by 2g. Okay. All right, so we have to do a lot of interesting problems. See, this theoretically we are done. Let me give you the homework also. You can go to both the exercise and you can see there is a topic clearly mentioned, motion under gravity. See, that is a section D actually. Can you see page number 5? Page number 5. So let me mention what you are supposed to solve as a homework. Page 5. So solve motion under gravity. Then again come to the, this is part 1. Then page 6. No, page number 7. So they have written that as motion under gravity. So you can start solving. Many questions you will see in the next lecture, but you can still start. And we'll solve some challenging problem in the next lecture. Mostly all questions will be interesting and challenging, which will face in various textbook. Okay. So you can start solving because it's easy, because you know the approach, and you'll feel really good if you can solve even those questions which I haven't discussed. It will help you in enhancing your confidence level with the topic. Next lecture, we are going to finish this entire topic, and we'll see something really interesting, some question up to Olympiad level also. Using simple equation, we can solve every question. Okay. So for now, goodbye and take care. See you in the next lecture.
Bye, sir. Thank you, sir.
Yeah, bye. Have you understood today's lecture?
Yes, sir.
No, great. See you in the next lecture.
Yeah. Bye, sir.
Bye, sir.
Bye.